exciting episode of Technology for All Academy Maths program. My name is Talama Kobe. I'm your tutor and the founder of Technology for All Academy, a division of Above Supply and ICT Solutions. Our focus for today will be on quadratic functions. The equation for quadratic function is y is equal to ax squared plus bx plus c. That's our standard form. And we also have y is equal to a into x plus p all squared plus q. That's our vertex form. Our focus for today will be on using our graph to find our equation. Already, when we check on the graph that we are given, we can see that we already have a lot of information that can help us to find our equation. For example, to start with, we can see that our graph is facing upwards. And then, if our graph is facing upwards, it means our A is greater than 0 or is positive. And then it means that we also have our minimum turning point or vertex. So the way to remember it, or the way I remember it, is that my graph facing upwards means I have a happy face. I have a happy face because of what? My problems are little or have minimum problems, and that makes me positive in life. So I'm happy because of I have minimum problems, and it makes me positive in life. And if my graph is pointing downwards, that means I have a sad face. And then in order to know my A, or to remember my A, or the shape of my graph, what I do is that I'm saying I know my A is less than 0, or my A is negative. And for me to remember it, the way I remember it is that I say I'm sad because I have maximum problems, and that makes me negative in life. Meaning my turning point is positive, I have a maximum turning point. So it's my maximum problems, and it makes me sad, my sad face. That's why I'm negative in life, my negative A. So our A, it gives us the shape of our graph. So by seeing that our graph here, the graph that we are given is facing upwards, we already know our A must be positive. Whatever equation that we are going to calculate, it must have a positive A when we get to our answer. And then what do we have again? We have this dotted line. This dotted line is our line of symmetry, or axis of symmetry. What does the line of symmetry or axis of symmetry do? It divides our graph into two equal parts. Meaning, from here to here, it's equal from here to this side. And again, what do we have on our graph? We have this point, -1 and 3. What are these -1? Okay, before I can move on, our axis of symmetry is equal to 1. Where do we get that 1? This one is where our axis of symmetry cut the x-axis. That's where we get our 1. And then we also have -1 and 3. Those are our x-intercept. What is an x-intercept? X-intercept is a value on our x-axis where our graph passes, our parabola parabola passes or cuts the x-axis. And we also have the y-intercept, which is -3. And what is a y-intercept? Our y-intercept is the y value on the y-axis where our parabola cuts or passes the y-axis. And then we also have -4, this point here, this point here, our turning point. This is our turning point. That point, it's 1 and -4. Our x is 1, our y is -4. This is our vertex or turning point. In this equation, y is equal to a into x plus p all squared plus q. Our q is our y value of the turning point, which is -4, and our p is our axis of symmetry, which is y. So p and q in the vertex form is our turning point. And then what else can we get, or can we already see or imagine from the graph? What can we get from the graph? Another thing that we can get from the graph, as we can see, our graph, those arrows shows that our graph is going all the way up. It doesn't goes non-stop. So because of those arrows showing that it goes non-stop, we know that our domain, the x value, our domain is x is an element of -infinity to infinity. D for domain. Our domain, its x is an element of -infinity to infinity, using our regular brackets. And we can also get our range. Our range is from the turning point in our heavy phase, because we have minimum problems, which is our minimum turning point. So we start from our negative going upwards to get our range. So for our range, R for range, our range is y is an element of, we make a square bracket to show that it is included, -4 to infinity, and we close with a regular bracket. That's our range. And if we had a set phase, our domain will still remain the same. Our domain is always -infinity to infinity. But our range, if it was a set phase, meaning we are set because of what? We are having maximum problems. Maximum problems equal what? Maximum turning point. So in our case, let's just say maybe for interest sake, our turning point, our y value, it was 4. So our range will be what? Our range will be this way if we had a set phase. Range is y is an element of regular bracket -infinity to 4 square bracket to show that it's included, or that's where we end. Let me take it off. Okay, before I can take it off, let me repeat again. Domain, our domain It's always x is an element of minus infinity to infinity. Our range for happy phase R, our range for happy phase is y is an element of minus 4 to infinity. Remember that for minus 4 we make a square bracket to show that it's included. If it was a set phase, meaning we have maximum progress, maximum tipping point, then our range was going to be y is an element of minus infinity, regular bracket, to 4 square brackets to show that 4 is included. Okay, let's carry on. So from the information that I got from my graph, as you see, I wrote it down here. My x-intercept, I have minus 1 and 3. My y-intercept, I have minus 3. At my vertex or turning point, I have 1 and minus 4. So I can use my x-intercept and my turning point to get my equation. Or I can use my x-intercept and my y-intercept and x value, which is 0, to get my equation. Let me show you. In this instance, let me start with my turning point. The equation that we use to get our quadratic equation or our equation for parabola, we are going to use y is equal to a into x minus x1, close bracket, second bracket, x minus x2, and then x1 and x2, that's where I substitute my x-intercept. And then y and x, you substitute any values that you have on your graph that are not x-intercept. So in this case, I'm going to start with my turning point. I'm going to say minus 4 is equal to a into my x is 1 minus into minus 1, close bracket. The second bracket, 1 minus my second x-intercept, which is 3, minus 3. So I'm going to have minus 4 is equal to a to 1, my 1, no, a into 2, my 2. How did I get it? How did I get my 2? Negative by negative is positive. So it's 1 plus 1 is equal to 2. And then the other bracket is 1 minus 3, which is equal to what? Minus 2. So I'm having minus 4 is equal to 2 multiplied by minus 2 is 4. Multiplied by a, I have minus 4a. Divide both sides by minus 4. Therefore, my a is equal to 1. That's the value that I get for my a. Before I can carry on to get my equation, let's use minus 3 and 0 to see if we will also find the value of a to be 1. Okay, let's start again. Let me erase this 1. Okay. Our y is minus 3 is equal to a into our x value is 0. 0 minus into minus 1, close bracket. So the second bracket is 0 minus 3. have minus 3 is equal to a into negative by negative gives us positive. Then we have 1, 0 minus 3 is minus 3. So we have minus 3, it's equal to a multiplied by 1 multiplied by minus 3 is minus 3a. We divide both sides by minus 3. Therefore, our value of a, therefore our a is equal to 1. As you can see, we still get a 1. Let's move on. We now know our a is 1. So to calculate our equation, we say y is equal to our a, it's 1 into our bracket x minus x-intercept into minus 1. This bracket, the second bracket, we have x minus x-intercept, which is 3 minus 3, close bracket. And then we have the next step, y is equal to, we can drop our 1, we know 1 multiplied by any value is that value. So we can drop our value, we can drop our 1. Then in bracket I'm going to have x, negative by negative gives us positive 1. Then the second bracket, still x minus 3. And my following step is to multiply out the brackets. So y is equal to x by x, we have x squared, and then x by minus 3, it's minus 3x, 1 by x, we have x, it's a positive 1 by x, it's positive x. Positive 1 by negative 3, it's negative 3. Then let's simplify it. We subtract whatever can be subtracted and we add whatever that can be added. Y is equal to x squared minus 3x plus x gives us minus 2x. And then we bring down our minus 3. That's our equation. Our equation is y is equal to x squared minus 2x minus 3. Are we happy with our equation? Yes, we are happy with our equation. Why am I saying that we are happy with our equation? Our value of a is positive, which is what? Positive 1. Meaning we are having positive 1x. And as you can see, our graph, how does it look? It's a happy face. Happy face means what? Our a is greater than 0. And as you can see, our a is greater than 0. I really hope you enjoyed the lesson of today. In our following lesson, we'll be learning how to get or how to plot our graph from the equation that we are given. We'll be working with the equation and trying to find to plot the graph from our equation. Hope you enjoyed it, and please guys, don't forget to subscribe and to also leave comments, whether positive or negative. Comments are highly appreciated. We grow from their comments. They make us strong. They make us learn from our mistakes. And also, please again, give us thumbs up if you like the video, and also if you didn't like the video, give us thumbs down so that we can know where to improve And also, when you give us a thumbs down, tell us where we went wrong so that we can know how to improve and to get it right the next time. And lastly, again, I just want to emphasize on it. Please, guys, don't forget to subscribe. Have a blessed day, and we love you. Thank you.